Hello all, welcome to the new video. In this video we'll be discussing about the working of ring modulator circuit. Ring modulator is a popular circuit used in the generation of DSPSC signal, where DSPSC stands for double sideband suppressed carrier modulation. So before going further, we'll discuss some things about the conventional EM modulation. Say, so I have represented the conventional EM systems in terms of horse carrying the luggage or goods, you can say. So as you can see, our goods is this. We are interested in transferring goods from one place to another. So we require some sort of carrier to carry the goods. So this is the, we can consider a horse as a carrier signal, and this goods as the message signal. So what used to happen in amplitude modulation is a lot of power required to transmit the carrier would be very high compared to the message signal. So you can say, as if you want to transfer goods from one place to another, the amount of the money which you spend or invest would be like, you would spend most of the money on horse itself instead of the actual goods. So our main intention was to just send the goods. We don't want how it goes from one place to another. You can send it by horse or by donkey or by any other means. You can think of any other means. However, in signals and systems, what they had, they did a lot of research as like a lot of money has been wasted on horse. So in the same way, they thought that there is like more power is required to transmit the carrier alone. So this is of no use to us, no use to us. So why we invest more power in carrier signal instead of message signal? So that was the question. So that's how we moved on from amplitude modulation to DSBSC modulation. In that we suppress the carrier. So we can suppress the carrier in DSPSC modulation in many ways. So one such way is using ring modulator circuit. So as you can see, we have a message signal M of t, and then there is a carrier C of t, and this is our output X of t. So we'll see how this works. So this is a ring modulator circuit. As you can see, the diodes D1, D2, D3 and D4 are arranged in the ring format, hence the name ring modulator. So coming to the ring modulator, in ring modulator circuits, the carrier signal which we usually use is of square wave, that is square wave signal. So as you can see, the square wave signal C of t, it has amplitude of +1 in the positive half cycle and amplitude -1 in the negative half cycle. So let's see the working of the ring modulator circuit in the positive half cycle of the carrier signal. So during positive half cycle, the diodes D1 and D3 are forward biased, whereas diodes D2 and D4 are reverse biased. So we get a ring modulator in this format. So as you can see, since the turns ratio is 1:1, the message signal, you can imagine this as the message signal getting multiplied by the carrier wave. Since the carrier wave is an positive half cycle, we multiply the message signal by C of t, that is +1. So we get the output X of t. So X of t is equal to M of t into C of t. This is during positive half cycle. Because as you can see, the message signal will appear here across the secondary of the transformer T1. So this is the primary of T2, primary transformer. Since it is connecting in the direct fashion, you can say as it is multiplied by +1. So that's what happens in the positive half cycle. We get a modulated signal. So in the same way, during negative half cycle, the diodes D1 and D3 are reverse biased and they are out of the circuit, whereas diodes D2 and D4 are forward biased. So in that case, our carrier signal has amplitude of -1. So this is during negative half cycle. So since the turns ratio is 1:1, this is transformer T1 and this is transformer T2. Turns ratio is 1:1 here. So what happens? You can see the M of T will appear across the secondary of transformer 1. This is T1. So this message signal is getting applied to the primary of transformer T2 in reverse direction. Okay, so we are not this plus is connected to the in this fashion to D, and this the negative of this message signal is connected to the B. So as you can see, it is reversed. So we can think this of multiplying our message signal by -1. So this is nothing but amplitude of carrier C of T. So x of t will be m of t into c of t in even in this case. However, our total modulated signal will be 180 degree out of phase. That is, you can see this is our modulated signal. I have written here in negative half cycle diodes are forward bias and connects the secondary of the transformer T1 to the primary of T2 in reverse connection. This results in the 180 degree shift. So this is the 180 degree shift which we are talking about. Okay, so that's how it works. You can read more about ring modulator in my website here. That is, as you can see, this is the ring modulator circuit. So one question everybody will be having, usually they don't cover it in the classroom. So you can ask us how carrier is suppressed. So let's see, if the message signal is 0, there is no message signal, just we have applied the carrier wave, then what happens? Okay, so that I have explained here. So let the input m of t be 0. So this let the message signal be 0. Then there is just a carrier signal in the ring modulator circuit. So what happens? The current divides equally here in the primary winding of T2 transformer. This is T2. So the current in the upper half of the transformer produces a magnetic field which is equal and opposite to the magnetic field produced by the current in the lower half. So they cancel out each other. So we get 0 output. That is, carrier is suppressed. So that's how it works. So only if we apply message signal, then only we can see the output. Otherwise, there will be no output in DSPSC modulation. So if m of t is equal to 0, x of t is equal to 0. Okay. So because x of t is m of t into c of t. If m of t is 0, c of t will be h of t will be 0, because the carrier is suppressed in ring modulator circuit. So in case, let me explain in terms of horse and goods. So what we have done in case of DSPSC is we have reduced the money which we had invested in this horse. Instead, what we are doing, we have found a new way of transferring the goods from one place to another. So thanks for watching. For any doubts, please use the comment section, and please subscribe. Thank you. And you can refer to the ring modulator circuit here. You can visit this site www.acquitworld.com. So go there and in search panel search for ring modulator. You will see detailed explanation. Thank you.